Jai Hind to all. My name is Manoj Kumar, Assistant Professor, Department of Computer Science and Engineering, Ajay Kumar Garg, Engineering College, Ghaziabad. Today in this video lecture, we will learn about the Peterson solution for critical section problem. This is the table of content that I will cover in this video lecture. First, we will see about the process synchronization, and after that we will see the critical section, what is critical section and what are the necessary conditions for the critical section. Then what are different synchronization mechanisms used for process, concurrent process in operating system, and there is a critical section problem. So different type of solutions are available for critical section problem, like the Peterson solution, Decker solution. So in this lecture, we will particularly concern on the Peterson solution of the critical section problem, and in the last we will see the advantage and disadvantage of the critical section problem. Okay. So process synchronization. What is process synchronization? Actually, in case of concurrent process, when concurrent process execute and they share a common resource, they work on a common data, then their action for accessing that common resource, that may be a physical resource or that may be a logical resource, like it may be a particular variable. So that access must be synchronized so that each process can complete its operation successfully without any conflict. So process synchronization is a mechanism by which we provide the access of shared resource to the concurrent cooperating process in a synchronized manner, so that each process can perform its task successfully. So the main objective of process synchronization is to ensure that multiple processes access shared resource without interfering with each other, and to prevent the possibility of inconsistent data to the concurrent access. Okay, so this is the main objective of the process synchronization, and there may be two things. Suppose there is a variable A and there are two processes P1 and P2. So there are two things. First one is the sequential access and second one is the concurrent access. So whenever these two processes are executing concurrently, it means either P1 followed by P2, and second case is either P2 followed by P1. If the processes are executing sequentially, then there is no need of synchronization. We can apply synchronization, but there is no need. Synchronization need arise when these two processes execute concurrently and they shared a common resource. They want to access a common resource. In that case, there is a need of process synchronization, and different type of mechanisms are available for process synchronization. Especially in case of operating system, the semaphore is used for process synchronization. Semaphore is an integer variable, basically the binary semaphore, which value may be either 0 or 1, that is used for the process synchronization in case of operating system. So process synchronization ultimately is a mechanism by which we provide the access of the shared resource to the concurrent process in a synchronized manner, so that each process can execute its task efficiently. There are two types of process: independent process and cooperating process or concurrent cooperating process. Independent process are those processes which don't interfere the working of each other. Okay, it means P1 and P2 both are separate. They don't exchange any kind of data or any kind of information with each other, or they don't share a common resource. So whenever the process execute independently without affecting the working of each other, and they don't exchange any information, then those type of process is known as the independent process. Second one is the cooperative process. Cooperative process are those processes whenever the working of one process affected by the other process, or when these process there is any kind of information exchange or data exchange within the process, then they are known as the cooperative process. Like P1 and P2, if they want to exchange any information with each other, or if they shared a common variable, then in that case these are the cooperative process, because working of one is affected by the other. Like this is the example of producer consumer program. In producer consumer problem, there are two processes. One is the process producer, second process is the consumer, and consumer process consume the data item produced by the producer process. It means working of consumer process is affected by the working of producer process, because until and unless the producer process doesn't produce the data item, then consumer will not consume. Because to consume a data item, there must exist a data item, and who will generate the data item? Data item will be generated or produced by the producer process. So these in this problem, producer and consumer problem, producer and consumer are the cooperative process. So process synchronization is basically required for the cooperative process. Next one is the critical section. What is critical section? Critical section is a code segment that can be accessed by only one process at a time. It means critical section basically is a piece of code in which the concurrent cooperative process access the shared resource, like it may be any table or it may be a variable. They update, like they perform the updation operation on the table, or they any process want to increment or decrement the value of the common variable. So that particular piece of code in a program, that is known as the critical section. So every process, concurrent process, have its critical section. This is the basic structure of the critical section. First one is the entry section, second critical section, exit section, remainder section, and true. Basically this is the structure of the solution for critical section problem. It means whatever solution we will design for the critical section problem, that solution must follow this structure. In entry section, what will happen in an entry section? In entry section, suppose there are two processes, P1 and P2. They shared a common variable A. P1 want to increase the value of A by 1 and P2 want to decrease the value of A by 1. Okay, so what is the role of critical section here? It means critical section says that whenever the process P1 is updating the value of A, it means whenever the first process is using the common variable or shared variable, if at the same time other process P2 also want to update the value of A, also want to access the value of A, then this access of P2A at that time must be prevented. This is the main objective of the critical section. Okay, so whenever the first process is using the variable A, shared variable, and if at that time the second process also want to access the A, then we have to prevent this access of P2 to A until and unless P1 complete its task. So this is the objective of critical section. It means access of this shared resource must be in mutually exclusive manner. In the same way, vice versa, if P2 is using the variable A, shared resource, is updating the value of variable shared resource, if at that time process P1 want to access the variable A, then at the time we have to prevent the access of P1 to A. Okay, it means only one process can enter in its critical section. So we have to design a solution by which we can achieve this. For that particular, this structure is exist. First one is the entry section. Basically, entry section, in entry section, it is decide whether a process is allowed to enter in critical section or not. It means this is a permission section. Here the permission of a process to enter in critical section either will be accepted or either will be rejected. For example, whenever P1 want to access A, if at that time A is free, it means P2 is not using A, then we will grant the permission. It means process P1 will enter in critical section. What? If whenever P1 is want to access A, if at that time A is not free, process P2 is using A, then process P1 will wait until the P2 complete its task and make the free A. Okay. So this is the entry section. Second one is the critical section. In critical section, once the process enter in critical section, then it perform its task. After that, exit section. In exit, after completing the critical section, process come in exit section. Basically, in exit section, the process which just exited from the critical section, that process give the chance to other process to access the shared resource. It means if P2 is completed its operation on A, then next chance should be given to process P1. Next one is the remainder section. Remainder section, in remainder section the code non-shareable code is there. Okay, this is the basic structure of the critical section solution. Now these are the conditions that a critical section solution must be satisfied. First condition is the mutual exclusion condition, and mutual exclusion condition state that if a process is executing in its critical section, then no other process is allowed to enter in critical section. It means if there are two processes P1 and P2, so whenever P1 is executing in its critical section, if at the same time P2 also try to enter in critical section, then permission of P2 should not be allowed. It means at a particular instant of time, only one process can enter in its critical section. Second condition is the progress condition. Say if no process is executing in the critical section and other process are waiting outside the critical section, then only those processes that are not executing in the remainder section can be participated in deciding which will be enter in critical section. It means suppose there are two processes P1 and P2, both want to share a common resource A. So if A is free and P1 want to enter in critical section, then first we will see that P1 is in remainder section or not. If P1 at the time is in remainder section, then P1 can access A and enter in critical section. It means progress must be there. Such type of scenario is not there, like A is free and neither P1 is able to access the A or neither P2 is able to access the A. Okay, if this shared resource is free and there are two processes P1 and P2, if P1 want to enter in critical section or P2 want to enter critical section, then any one of them should allow to enter in critical section, or any one of them should allow to access the A. It means there must be a progress in the system. Third condition is the bounded wait condition. Bounded wait condition basically decide a limit. It means how many times a particular process can enter in its critical section. So we have to apply a limit for that entry. That is why this is known as the bounded wait. It means suppose first access of this shared resource is given to process P1, then this should not be happen that again and again P1 is entering in critical section and P2 is waiting for from so many times. Okay, so how many times a particular process can enter in its critical section? There must be a limitation so that the other process which is waiting to enter in critical section or which is waiting for the shared resource, that can use that. Okay, so every solution follow this must satisfy these three conditions for the critical section solution. Okay, synchronization mechanism with busy waiting and without busy waiting. These are some other solution like the log variable, test and set variable, Deckel algorithm and Peterson algorithm. These are the solution for critical section. In this video lecture, our major concern is to explain the Peterson algorithm or Peterson solution for the critical section problem. So this is the Peterson solution. Peterson solution, actually this is the basic structure of the Peterson solution. What happen in case of Peterson solution? We basically use two variables. First, we use the flag variable corresponding to process. Suppose there are two processes P1 and P2. Now there are two variables. First variable is turn and second variable is a boolean type flag variable. If flag suppose flag of 0 means for flag variable corresponding to P1 and flag of 1 means flag variable corresponding to P2. Okay, so flag variable basically represents that whether a particular process is interested to enter in critical section or not. If the flag of P1 is equal to 0, it means process P1 don't want to enter in critical section. If flag of P1 is 1, it means process P1 want to enter in critical section. We can either use here true and false. Okay. In the same way, if flag of P2 is equal to 0, then process P2 doesn't want to enter in critical section. and if flag of P2 is equal to 1, then P2 want to enter in critical section. So basically this flag variable indicates that whether the process want to enter in its critical section or not, whether the process is interested to enter in critical section or not. And here the turn variable basically represent whose turn it is to enter in critical section. Okay, so we have to design a solution of critical section problem which must satisfy these three conditions: mutual exclusion, progress, and bounded betting. And Peterson solution satisfy all these conditions, all these requirements of the solution for the critical section problem. So here this is the common structure. If there are two processes P0 and P1, then process P0 also follow this structure and process P1 will also follow this structure. And the limitation of Peterson solution is that it is limited up to only two processes. There may be more than two processes in process synchronization problem, but this solution is applicable up to the two processes. It means if two processes are using a shared resource or they want to entering in critical section, then how we can provide the permission to both the process. So for a particular process, suppose there is process I, this is the general term. At first, the process which want to enter in critical section, it will declare its flag variable as true. It means if process P1 want to access the shared resource or want to enter in its critical section, then at first it will declare its flag variable as true or 1. Again, next statement is turn is equal to j. It means if process P1 like flag of 0 is equal to 1, now it will check what is the value of turn variable, and since turn is an integer variable, so its value will be either I or j. It means its value will be turn is equal to will be either 0 or 1. Both value cannot belong at the same time. Okay, so at first, if first process will wants to enter in critical section, then again it will check the turn is, if the turn is equal to j, it means if process P1 want to enter in critical section but turn is equal to 1, then what it will check? It will check this condition. If flag of j, it means what is the flag status of this process P1. Suppose flag status of P1 is also 1. It means P1 also want to enter in critical section and turn is also 1. Okay. So if these two conditions are satisfied, it means the flag of second process P1 is also 1. It means P1 is also interested to enter in critical section and turn is equal to j. It means turn is also initialized to second process P1. Then what will happen? This is the semicolon. Basically, this represents the busy waiting condition. It means in that case, the process P0 will wait until the P1 completes its critical section and exit from the critical section. Okay. Again, see, whenever any process want to enter in critical section, then at first it will declare its flag variable as true. So flag of 0 is 1 if P0 want to enter into critical section. Then in the next instruction, it will check the value of the turn variable. If it found that turn is equal to j, then it means turn is equal to 1. Turn is initialized with other process. Then it will check the space condition specified in while loop. Then it will check whether the flag of j is 1 or not. It means whether the process P1 want to enter in critical section or not. Suppose flag of 1 is also 1. So since flag of 1 is also 1 and turn is also initialized with 1, in that case process P1 come to know that I have to wait until the process P1, process P0 come to know that I have to wait until the process P1 completes its execution in its critical section. So it will wait. As soon as the process P1 will exit from its critical section, then it will initialize its false, its flag variable at 0. So when flag will 0, then process P1 can enter in critical section, and after exit it will initialize it false. It means what is the common solution? So whenever a process want to enter in critical section, then at first it will initialize its flag variable as true. Then when it will exit from critical section, it will initialize its flag variable false. So it means this statement is the exit section, and here it is giving the chance to the other process. Okay, so for example, this is the process P0 and process P0 and process P1. So first process P flag of 0 is equal to true, then it will check that turn is equal to 1. If this condition is, both conditions are true, then process P0 will wait, because P1 is in critical section. Turn is also initialized with P1 and P1 is also interested, so it will wait. As soon as P1 come, this condition become false, then process P0 will enter in critical section, and when P0 will exit from critical section, it will initialize its flag variable as false. Same code will be followed by the process P1. Whenever P1 want to enter critical section, then it will initialize its flag as 1, and again it will check the turn of value of turn variable, and it found that turn is equal to 0. It means turn is initialized to process P0. Then it will check these two conditions. If flag of 0 and turn is equal to 0, it means process P0 also interested in critical section and turn is also initialized to 0, then process P1 will wait. This is the busy waiting condition, do nothing. Process P1 will wait until the process P0 come out from the critical section. Okay, whenever this condition become false, then process P1 is allowed to enter in critical section. It will execute, complete the task of the critical section, and whenever it comes from critical section, exit from critical section, then it will initialize it with false. Okay, so this is the Peterson solution. Here we achieve the synchronization with the help of two variable, flag and turn variable, and this solution satisfy the all the three requirements, like mutual exclusion. It means at the one time only one process can enter in critical section, either P0 or P1, because that is achieved with the help of turn variable. Because value turn is an integer variable, its value may be either 0 or 1 at a time. So in case if both processes are interested to enter in critical section, process this is also true, this is also true, then which process will allow, that is decided by the help of turn variable. So mutual exclusion is achieved. Second condition is the progress. So whenever a particular process exit from the critical section, or whenever both process want to enter in critical section, so any one of them will allow to enter. It means such type of situation will not happen that permission is not granted neither to P1 or neither to P0. So either P0 will be in critical section, either P1 in critical section. So progress condition also satisfied. Next condition is the bounded wait. So this statement here, this statement and this statement represent the bounded wait condition. It means whenever a particular process is exited from the critical section, then it is giving the chance to other process to enter in critical section, because it initializes its flag as false. So bounded wait condition is also satisfied. So all three conditions, mutual exclusion, progress and bounded wait, that must be satisfied by the Peterson solution of the critical section problem. Advantage of Peterson solution: it assures the mutual exclusion, it assures the progress, and it also assures the bounded waiting. Okay, and it is easy to implement. Disadvantage solution of this solution is that it is limited only up to 2 processes. It means if more than 2 processes, for a problem where more than 2 processes are there which shared a common resource, this solution is not applicable. And other solution is that it use the busy waiting condition. Okay, so in this video lecture we have discussed about the process synchronization, independent process, cooperative process, critical section, what is critical section, what are different requirements of critical section, what are different solutions of the critical section, and basically the major concern is to explain the solution, Peterson solution of the critical section problem.